Minimal Linux desktops are steadily replacing feature-heavy ones because the way people use computers has changed, and expectations around speed, control, and efficiency have shifted with it. For a long time, desktop environments tried to imitate the look and behavior of traditional operating systems by adding more features, more visual effects, more built-in tools, and more background services. The assumption was that users wanted everything included by default, so they would never have to install or configure anything themselves. Over time, however, this approach created environments that were heavier, slower on older hardware, more complex to maintain, and often filled with components that many users never touched. As workflows moved toward browsers, terminals, and specialized applications, the value of massive integrated desktop suites began to decline. Minimal desktops emerged not as a downgrade, but as a refinement, a deliberate reduction that prioritizes responsiveness, clarity, and user choice. One of the biggest reasons for this shift is performance. A minimal Linux desktop consumes fewer system resources because it runs fewer background services, launches fewer daemons, and loads fewer graphical effects. This directly translates into faster boot times, lower memory usage, reduced CPU load, and smoother responsiveness under pressure. On modern high-end machines, this may sound less important, but even powerful systems benefit when the interface layer stays out of the way. The gains become dramatic on older laptops, small form-factor PCs, virtual machines, and single-board computers where every megabyte of RAM and every CPU cycle counts. Instead of replacing hardware to keep up with software demands, users can switch to lighter desktops and extend device life by years. That makes minimal desktops not only technically appealing but also economically and environmentally sensible. Another major factor is control. Feature-heavy desktops often make decisions on behalf of users. Which services start automatically, how windows behave, how files are indexed, how notifications appear, and how system integration works. While this is convenient for newcomers, advanced users often find it restrictive. Minimal desktops flip this model. They provide a basic framework window management, panels or bars, simple settings, and leave the rest to the user. Instead of disabling unwanted features, users add only what they need. This inversion reduces friction. Rather than fighting defaults, users build their environment intentionally. Control is not hidden behind layers of configuration panels. It is expressed directly through simple config files, scripts, and modular components. Customization is another driving force. Feature-heavy desktops typically offer customization through graphical settings tools, but those tools expose only what developers anticipated users would change. Minimal desktops are often configured through plain text files or small scripts. That might sound harder at first, but it unlocks nearly unlimited flexibility. Users can define key bindings, window rules, startup programs, layouts, themes, and automation with precision. Configurations can be version controlled, copied between machines, shared online, and restored instantly. This makes the desktop environment reproducible. Developers and power users especially value this because it turns the desktop into part of their toolkit rather than a static interface. Workflow evolution also plays a role. Many modern users spend most of their time in a browser, a code editor, and a terminal. They rely on cloud tools, containerized environments, remote servers, and cross-platform applications. In this context, a giant desktop suite with built-in media managers, file indexers, search frameworks, and integrated service layers becomes less relevant. Minimal desktops align better with task-focused workflows. They stay invisible while applications take center stage. Tiling window managers and minimal shells support keyboard-driven navigation, workspace separation, and predictable window placement, which increases efficiency for users who juggle many windows or tasks simultaneously. Reduced visual clutter leads to faster cognitive processing and fewer distractions. Stability and reliability are additional benefits. Larger desktop environments have many interdependent components. When one part fails or updates incompatibly, the entire environment can become unstable. Minimal desktops have fewer moving parts. Their components are often loosely coupled, meaning a failure in one utility does not cascade across the system. Updates are less risky because there are fewer layers involved. Troubleshooting becomes simpler too. When something goes wrong, users can inspect a small configuration or replace a lightweight component instead of debugging a complex integrated framework. Security considerations also favor minimalism. Every running service and integrated feature increases the attack surface. Feature-heavy desktops may include network services, device discovery tools, indexing engines, and background helpers that run whether the user needs them or not. Minimal desktops tend to run only what is explicitly enabled. Fewer processes listening, fewer parsers running, and fewer privileged helpers reduce exposure. While security always depends on many factors, reducing unnecessary components is a well-known defensive principle. Minimal desktops naturally follow that principle. There is also a philosophical element behind the movement. Many Linux users value transparency and composability. They prefer systems built from small, understandable parts that work together through clear interfaces. Minimal desktops embody this philosophy. Instead of a monolithic environment that tries to do everything, they encourage combining independent tools. A launcher here, a panel there, a compositor if needed, a notification daemon, a clipboard manager. Each piece can be swapped without rebuilding the entire desktop. This modularity mirrors how many Unix-like systems are designed at their core. It feels consistent with the broader ecosystem values. Resource efficiency matters not only for individuals but also for organizations. Educational institutions, labs, and companies often maintain large fleets of machines with mixed hardware quality. Deploying a minimal desktop reduces baseline resource usage, allowing more machines to remain productive. In virtual desktop infrastructure and remote environments, lighter desktops reduce bandwidth and server load. This makes them attractive in cost-sensitive or large-scale deployments. When multiplied across hundreds or thousands of systems, small efficiency gains become significant savings. The rise of containerization and remote development has further reduced dependency on desktop-level features. Developers increasingly work inside containers, remote shells, or browser-based IEs. Their local desktop mainly serves as a launcher and window organizer. A minimal environment is perfectly suited to that role. It does not compete with or duplicate capabilities already provided by specialized tools. Instead, it provides a stable, low-overhead frame around them. As more workflows move toward remote execution and local orchestration, heavy desktop integration loses importance. Keyboard-centric interaction is another reason minimal desktops are gaining popularity. Feature-heavy environments often emphasize mouse-driven navigation and layered menus. Minimal desktops frequently support or prioritize keyboard shortcuts for launching apps, switching workspaces, moving windows, and executing commands. This reduces hand movement, speeds up repetitive tasks, and improves accessibility for users who prefer not to rely on precise pointer control. Once learned, keyboard workflows can be dramatically faster than graphical navigation. Minimal desktops make such workflows first-class rather than optional. Startup time and perceived responsiveness strongly influence user satisfaction. Even if a heavy desktop eventually runs smoothly, long login times and delayed interface readiness create friction. Minimal desktops usually start almost instantly. Panels appear quickly, launchers respond immediately, and there is little background churn. This immediacy changes how the system feels. It encourages short, focused sessions because there is no penalty for logging in and out or restarting. Over time, that responsiveness becomes addictive, and returning to slower environments feels uncomfortable. Maintenance overhead is lower as well. Large desktops bundle many utilities that must be kept updated together. Their dependency trees can be deep, leading to complex update paths. Minimal desktops depend on fewer libraries and tools. Package conflicts are less common, and updates tend to be smaller. Users who enjoy maintaining their systems appreciate the reduced complexity. Those who automate system setup also benefit because scripting a minimal environment is straightforward. Install base packages, copy configuration files, install chosen utilities, and the system is ready. Visual simplicity contributes to mental clarity. Feature-heavy desktops often include animated transitions, shadows, widgets, badges, and layered panels. While attractive, these elements can distract or overwhelm. Minimal desktops present fewer visual signals. Windows, borders, and text are emphasized over decoration. Many users find that this reduces cognitive load and improves concentration. The interface becomes a quiet backdrop rather than an active participant. This is especially valued in writing, coding, and research tasks, where attention is precious. Community culture has accelerated the trend. Users share configuration files, screenshots, and setup guides that demonstrate how powerful minimal environments can be. Seeing elegant, efficient desktops built from lightweight components inspires others to try similar setups. Because configurations are text-based, they are easy to publish and adapt. This creates a culture of experimentation and incremental improvement. Instead of waiting for desktop developers to add features, users assemble their own solutions and share them. Hardware diversity also encourages minimal desktops. Linux runs on everything from old netbooks to modern workstations to embedded devices. A one-size-fits-all heavy desktop cannot serve this diversity well. Minimal desktops scale more gracefully. They can run without compositing on very weak hardware or add compositors and effects on stronger machines. The same core environment can stretch across device classes with small adjustments. That flexibility is hard to achieve with tightly integrated, feature-dense desktops. Another subtle factor is failure recovery. When a minimal desktop crashes or misbehaves, it is usually easy to restart components individually. Users can kill and relaunch a panel, window manager, or compositor without logging out. Config errors are often visible and fixable by editing a file. Heavy desktops sometimes require full session restarts or deeper resets because components are interwoven. Quick recovery reduces frustration and downtime. Minimal desktops also encourage learning. Because configuration is explicit, users gain insight into how their graphical environment works. They learn about window managers, display servers, compositors, hotkeys, and startup processes. This knowledge demystifies the system and builds confidence. Users who understand their tools can adapt them more effectively. Feature-heavy desktops tend to hide internals behind graphical settings, which is convenient but less educational. Battery life can improve under minimal environments. Fewer background tasks and visual effects reduce CPU wake-ups and GPU usage. On laptops, this can translate into measurable energy savings. While not the only factor in power consumption, desktop overhead is not negligible. Users who work on the go notice the difference when their systems idle quietly instead of constantly refreshing widgets and animations. There's also less risk of feature conflict. Heavy desktops integrate many subsystems: notifications, audio control, device management, search indexing, network management, and more. When users install alternative tools for any of these roles, duplication or conflict can occur. Minimal desktops usually start with none or only one of each category chosen by the user. This reduces overlap and confusion. The system behaves more predictably because each function has a single responsible component. Minimal desktops are not replacing feature-heavy ones for everyone, and that is important to acknowledge. Users who want a ready-made, fully integrated environment with graphical settings and built-in tools still benefit from heavier desktops. New users often appreciate strong defaults and discoverable features. However, as users gain experience, many realize they use only a fraction of what is provided. At that point, switching to a minimal desktop feels like removing unnecessary weight. The trend is not about superiority, but about alignment with user needs. The broader software world is also rediscovering minimalism. Lightweight editors, terminal tools, static site generators, and small composable utilities are increasingly popular. Minimal desktops fit naturally into this landscape. They act as glue rather than a platform. They do not try to be an ecosystem. They host one. That distinction resonates with users who prefer best-of-breed tools over all-in-one suites. In the end, minimal Linux desktops are replacing feature-heavy ones in many contexts because they better match modern priorities. Speed over spectacle, control over convenience defaults, modularity over integration, and clarity over abundance. They respect hardware limits, support advanced workflows, reduce maintenance burden, and empower customization. They turn the desktop from a prepackaged environment into a personal instrument. As computing continues to diversify across devices and workflows, environments that stay small, adaptable, and transparent will keep gaining ground.